Now, let's delve into the detail, right? Let's delve into the detail. The browser, okay, the browser construct this packet, okay, construct this packet, and it specifically tell the tell itself that I need to go through port 53, right? My destination port is port 53. Now, there's this concept of layering and networking. What do you mean by layer? In networking, we only when you're a browser, you're only responsible for displaying things. You're only responsible for displaying things. I don't, as a browser, I don't care about how this packet is being transmitted. I don't care about how the server generates the data. Right? What I'm interested in is in displaying. So how do I get my data? I tell somebody at some other layer. Right? It's like I am only interested in sending. Let's say, for example, I want to send a mail. I want to send a actual mail to my friend. Right? I don't need to deliver this mail. In fact, what I want to do is that I just go to the post office. I send this letter. I give it to the post office and says, okay, deliver this to my friend. Okay, I give him the address. This is exactly what the browser is doing, right? It tells my post office. So in this case, the post office is my network card. It says, I want to go to the server, the DNS server. I don't know where is he. I only know his address. His address is okay. His address is 101.64.128.10. Right? I know his address, and I know within this address he stays in level 53. Right? So I have his unit number. Right? His unit number is 53. Right? So I'm going to send to 53. And then I need to tell him what is my address, right? Because the response will come to me, right? So my address, I set up my address. I tell my address is, I tell my post office, the address is 192.168.1.101. And my block number, my unit number is 58819. Okay, so I stay in 5819. And so the server, after he responds to me, you will know that my unit is at this number, right? So you will actually goes back to the correct browser, right? Because for example, I can have many browser running on my PC, right? And each browser will have a small little address, different port, okay, different port, okay, and the server would I can go to the same server, everyone can go to the same server, and the response comes back will goes to the correct browser tag, for example. Right? So, and this is exactly how Wireshark identify this packet as a DNS packet, because it knows that the destination port is 53. So whenever the port 53 happens on the packet itself, Wireshark will identify it to be a DNS protocol packet. Right? So very simple. Huh? Okay. So there are some other details. You can actually go and search the internet for all the other details, such as the flag. Okay, such as the flag and the transaction ID. We need a transaction ID to identify, right? Because the response will tag to a transaction ID. This transaction ID is you generate, the client will generate a transaction ID, right? Also take note, right? Every time I enter a URL on the browser. In this case, I never specify the protocol. So I never specify the protocol itself. So the protocol could be HTTP or HTTPS, right? So Chrome, right? Chrome will actually send two requests to the DNS server. Not only would it ask for the address of www.microsoft.com, it will also ask the DNS server, do you happen to have the HTTPS address? Right? So you will actually fire off two requests. So over here you can see that there are actually two requests that is DNS, right? But we are only interested in the packet number 1 and packet number 3 because the response, the request is in 01 and the response comes in 03, right? And Wireshark has very conveniently gives you a link that says the response is in 3. If you actually click on this link, you will jump the pointer to the third packet. Right? So we're going to jump to the third packet itself. Oh no, we're going to take a look at the packet itself. Right? So request body, okay, the DNS request body is asking for the IP address of this address. Okay, and the query, you can see I drop down the query itself. The query is I'm going to ask for a type A address. Okay, this is the name. Okay, I'm going to ask for the host address. Right, and there are some other flags, like for example, I am going to recursively. That means I am going to ask the DNS server. And if this DNS server doesn't know the answer, you will ask the parent DNS and so on and so forth. So you will go and ask as many layers as is required until you reach the end, okay, which is what we call the root server. And the root server, if the root server doesn't know where it is, then you will basically return a series of server not found, server not found, server not found. So let's look at the response back. Right? So the response back is in packet number 3. You can see that the source and destination has been flipped. So in this case, the source comes from the server itself, okay, and the destination is my machine, right? And the summary very clearly tells you that this is a standard query response. Okay, and the response for this query, okay, and the answer is 101.42.73.205. Right, so this server, www.microsoft.com, is at this IP address. Right? So again, you can see that the when we go into take a look at the detail itself, okay, this is the source port comes from 53, okay, and the destination port is the port that we use to request for is 58819, right, and the length of the whole query is 59. You'll find that 59 refers to the length of this portion, right? It doesn't include the header. If you include the header, you'll be 95. So there's the header is actually the 95. The header is 95 minus 59, right? So the response, you can see the answer. The answer is the address itself, right? And DNS also give very some other details, like for example, the time to live is 1 day. That means uh, if you want to cache this address, you can only cache it for 1 day. So after 1 day, this this value could expire. So it's basically telling you what is the expiry date of this address, right? Uh, because there are times where the user, the server, will change his IP address, right? So it's very important that DNS server give this time to live, so that the client will know when to refresh and to get a new IP address for the server.